Welcome back. This is a pre-algebra lesson on scatterplots. Today we're going to construct and analyze different scatterplots. So what is a scatterplot? You've heard of a line plot and all different kinds of other graphs. Well, a scatterplot is a graph that shows a relationship between two different sets of data. It consists of coordinate points, and those points each represent both an independent and a dependent variable. Go ahead and pause the video and copy this into your notebook. Let's talk about these variables. If you remember from your science classes or other math classes, an independent variable is one that is not affected by anything else. It's actually the variable that you are in control of. You are changing and adjusting its outcome to see you're adjusting it to see what would happen to it. Where the dependent variable is the response to that. It's the variable whose value is determined by the independent variable. It's the result or the reaction of what the independent variable does. Go ahead and pause and copy this into your notebook as well. So what does a scatter plot tell us? Why is it different than other graphs? Well, it shows that there is a relationship between the two variables. Actually, it tells us if there is. So again, we're looking for a relationship. So there either is a relationship or there's not a relationship. And here's how we can tell. The closer the data is together, again, the closer it is together, and it looks very similar to a line. If the data is close together and looks like a line, then the stronger the relationship between those variables are. If they are not close together, if they're not clumped together and you can't really make it look like a line, then there's no relationship. Let's go ahead and take a look at this then. Here is how we would graph a scatter plot. We're going to use the first quadrant of a coordinate plane to create this scatter plot. The first thing that you would want to do is label your axes. Okay, so in all graphs there's an x-axis and a y-axis. So if you remember, this would be your x and this would be your y. And we had talked about before that your x-axis is always your independent. I'm going to go ahead and put that over here. It's your independent. It's the part that you are changing, you are in control of. And your y-axis is the result of that, the outcome. So that's your dependent axis. Okay? So today we're going to be looking at how does time affect the temperature of cold water in a cup as it sits on a table. So what are we going to look at then? Our independent axis will be our time. So we're going to be looking at time, and we are in control of how much time we leave that cup on the table. And our dependent axis, which is our y-axis, we'll see what is the result of that time that we leave there. That will affect our temperature. So we're going to be measuring temperature over time for the cup of water. And don't forget, all graphs to be complete need an ultimate title at the top. So you can name it anything you want. I'm going to go ahead and just label it cold water temps. Nothing very fancy. All right, there we go. All right, so let's go ahead and graph our data then. Here we have a table. And our table shows both our x and our y are ordered pairs of what is happening. If we leave it out for this amount of time over here, then the result is this. This would be our outcome, or our temperature. So as you can see, I've go ahead and labeled the axes, and I went ahead and added our values to our axis so I can plot these points easily. So let's go ahead and plot these points and see if there's any kind of a relationship or no relationship. So it says, as the first one says, as x is 5, so as x is 5, y is 1, okay? So as in 5 minutes, the temperature is 1 degrees, I guess. And after 8, at 8, it's 4. So we're going to go up to here. We're going to go up to 4 degrees. And at 12 minutes, it's 6 degrees, so 12 goes up to 6. And at this point, we can kind of see a trend. It kind of seems like as time goes on, the temperature gets higher. Okay, so the cold water becomes less cold. Let's see if that continues, if we can continue this trend. So at 15, then it is 17. Wow, this is quite a jump. So at 15, it goes all the way up here to 17. Quite a big jump there. At 13 minutes, it's 12 degrees. So we're back down, kind of halfway back between those 2 points. At 17 minutes, it's 18 degrees. So again, clear up here at the top. Oh, sorry, over here, I guess, one, but that's okay. We could go ahead and we can erase that one, but it's not critical at this point. Okay, and at 16 minutes, it's 11 degrees. So at 16 minutes, it's 11 degrees. Okay, so we're going to put that there. All right, so if we're looking at our data, it looks like it's starting over in this area, and then it's continuing in an upward trend. So we say, are they semi-clustered together? Does it seem like we could make a line? So it looks like for the most part, our data is clustered together in this general area. And so if we wanted to, could we create a line going through this? Now, a line doesn't have to, on a scatter plot, the line does not have to touch every value. It's just a line that generally goes through the center of the point, center of the data. So if we tried around here, this, let's say we could say, yeah, actually, we could create a line that kind of represents the data, kind of seems be a little bit above, a little bit below, and some are right on the line. So it does look like there is a strong relationship between these two. Very interesting. Okay, good to know. All right, tonight your turn page is this data below. I'd like you to copy this problem into your notebook, create your own scatter plot, and answer the questions. Make sure to put a title on your data, and then I want you to identify whether there seems to be a relationship with the data or not. And here's your data. Okay? Good luck. We'll see you next time.